Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. Find the number of possible palindromes that can be formed using these alphabets. So if you look at these alphabets, L, there are 3 of them, 2 M's are there, and 4 O's are there. Altogether, how many palindromes can be formed? A palindrome is a word, whether you read from the left or from the right, the spelling will be the same. Now, how many such palindromes are possible? Now, here you have an odd number of L's. Since you have an odd number of L's, one L should be in the middle, and the middle lane will pass through this L. Then remaining 2 L's are there. So, one L will be on this side of the line, and the other L will be on the other side of the line. 2 M's are there. So, one M on this side of the line, and the other M on the other side of the line. 4 O's are there. So, 2 O's on this side of the line, and the other 2 O's on the other side of the line. So you can see that this is a palindrome. Whether you read from the left or from the right, the spelling will be the same. How many such palindromes are possible? Now on this side of the line, you have 1 L, 1 M and 2 O's. 1 M and 2 O's. Now in how many ways can they be arranged? And for each arrangement, L, M and the 2 O's should be arranged in the same order when it is read from the right. As long as that is maintained, it will be a palindrome. So you have 1 L, 1 M and 2 O's. In how many ways can they be arranged? And for each arrangement, you will get a palindrome. So to calculate the number of arrangements, you can use this formula n factorial by k1 factorial into k2 factorial into k3 factorial. That is, n objects are there, k1 of them are same, k2 of them are same, k3 of them are same. All the n are taken out and arranged in order. Then how many arrangements are there? Directly substitute into this formula. Here n is equal to, here 1 plus 1 2, 2 plus 2 4. So n is equal to 4, out of which 2 of them are same, k1 of them are same. 4 factorial is 24, 24 by 2 gives you 12. So altogether 12 arrangements are possible, and for each of these 12 arrangements you can form a palindrome. Hence 12 possible palindromes, option A. Find the number of possible palindromes that can be formed using these alphabets. So if you look at these alphabets, 2 S are there, then 3 E's here and 2 E's here. So E altogether 5 of them, and 1, 2, 3, 4 P's are there. So altogether how many palindromes are possible? A palindrome is a word, whether you read from the left or from the right, the spelling will be the same. Now here you have an odd number of E's. Since you have an odd number of E's, one E will be in the middle. That is the only way in which you can form a palindrome. So one E has to be here and the middle line will go through like this. Now remaining 4 E's are there. Now out of the 4 E's, 2 E's will be on this side of the line and the other 2 E's on the other side of the line. Now 2 S are there. So one S will be on this side of the line and the other S will be on the other side of the line. 4 P's are there. So if you place the 2 P's like this, then the other 2 P's will be on the other side of the line. So you can see that this is a palindrome. Whether you read from the left or from the right, the spelling will be the same. Hence it is a palindrome. Now altogether how many such palindromes are possible? Now since you have an odd number of E's, one E necessarily should be at the middle. Then remaining two E's are there, one S is there, and two P's are also there. In how many ways can they be arranged? And for each arrangement, the two P's, one S and two E's should be arranged in the same order when it is read from the right. And from each arrangement you can form a palindrome. So 2 plus 2 4 plus 1 5. 5 alphabets are there, out of which 2 of them are same and another 2 of them are same. In how many ways can they be arranged? So you can use the formula n factorial by k1 factorial into k2 factorial into k3 factorial. That is, n objects are there, k1 of them are same, k2 of them are same, k3 of them are same. All the n are taken out and arranged in order. How many arrangements are there? Directly substitute into this formula. This formula gives you the total number of arrangements. Here n is equal to 5. 5 alphabets are there, out of which k1 of them are same, that is 2 e's are there, and another 2 p's are there. Now 5 factorial is 120. 120 by 4 you will get it as 30. So 30 possible ways of arranging 2 e's, 2 p's and 1 s. And for each arrangement you will get a palindrome. So altogether 30 possible palindromes are there. Hence option B, 30. There are 12 persons in a party, and if all of them shake hands with each other, how many handshakes are possible? So altogether 12 people are there, and how many handshakes are possible? Now the requirement for a handshake is 2 people. Now if you have a set of 2 people, immediately you will get a handshake. So how many sets of 2 people can you select? That many handshakes are possible. So from 12 you need to select 2. Now let us take a typical example. So 12 people are there, 2 people are necessary. For example, you select A and B, 2 people A and B. Now A will shake B's hand and you will get a handshake. Now instead of selecting A and B, now let us change the order. First you select B and then A. Now B will shake A's hand and you will get a handshake. But you can see that AB is actually same as BA. Now who initiates a handshake doesn't matter. The handshake is actually one and the same. So instead of AB, if you select BA, you will not get a different outcome or you will not get a different handshake. So 12 people are there. You need to select 2 people and order doesn't matter. So even if you change the order, you will not get a different outcome. In such cases, substitute into the combinations formula and you will get the total number of outcomes. Now the combinations formula is given like this. That is, n people are there. There may be objects also, out of which r of them are to be selected. And order doesn't matter. Even if you change the order, you will not get a different outcome. So in how many ways can you select r objects from n? That is given as n factorial by r factorial into n minus r factorial. This is the total number of outcomes that are possible. So how many handshakes are possible? Requirement for a handshake is 2 people. So from 12 you need to select 2. How many outcomes are possible? So just directly substitute into this formula. Here n is equal to 12, so n factorial by r is equal to 2, r factorial into n minus r. 12 minus 2 is 10 factorial. Upon simplification, here 10 factorial I will cancel with 12 factorial, remaining 12 into 11 by this 2. Here 2 divides 6 times, 6 into 11 gives you 66. So altogether 66 ways of selecting 2 people from 12. And for each set of 2 people you will get a handshake. So altogether 66 handshakes are possible. Now let us look at the typical situations where you can apply the combinations formula and you can get the answer. The combinations formula is like this. N objects are there. There may be people also, out of which r of them are to be selected, and order doesn't matter. The totally how many ways of selecting r from n people? So that will be n factorial by r factorial into n minus r factorial. This is the total number of ways in which you can select r objects from n objects. So let us look at typical situations where you can apply this formula to get the total number of outcomes. Let us say some points are given. Let us say n is equal to 10. 10 points are given. Now how many line segments are possible? The requirement for a line segment is 2 points. So how many ways can you select 2 points from the 10 points? So R is equal to 2. Now assume that these are the 2 points that you select. That is, let us say A and B. Now you select A, B, you will get this line segment. Instead of selecting A and B, you select B and A. You will get the same line segment. So if you change the order in which the 2 points are selected, you will not get a different line segment. AB is actually same as BA. The line segment is same. So 10 points are there. In how many ways can you select 2 points and order doesn't matter? Directly substitute into the combinations formula. That is, from 10 you need to select 2. So here n is equal to 10. So n factorial by r factorial into n minus r. 10 minus 2, 8 factorial. This many ways of selecting 2 points from 10 points. And each set of 2 points will give you a line segment. Now let us look at some more examples. Let us say some points are given. How many triangles can be formed? Requirement for a triangle is 3 non-collinear points. From each set of 3 non-collinear points, you can get one triangle. Requirement for a triangle is 3 non-collinear points. So how many sets of 3 non-collinear points can you select? That many triangles are possible. So if the question is how many triangles can be formed, just find out how many sets of 3 non-collinear points can you select from the given points. Let us take some more examples. Now let us say you need to select some people for a party. Now let us say 20 people are there. You need to select 5 people for a party. Now even after selecting the 5 of them can come in any order, or you can select them in any order you like, and the outcome will be the same. So from 20 people you need to select 5. That is, if you change the order in which you are inviting them, there won't be any difference. Ultimately those 5 will come for the party. So that's why it's a case of combination. So it will be 20C5. So substitute into the formula. So n factorial by r factorial into n minus r factorial. This many ways of selecting 5 people from 20. Now another typical situation where you can apply the combinations formula is cricket teams. Now let us say n is equal to 100. 100 people are there. For a cricket team you need to have 11 people. So r is equal to 11. In how many ways can you select 11 from 100 people? So directly substitute into the combinations formula. That is, even after selecting the 11, if you change the batting order, you will not get a different cricket team. A cricket team is same. 11 people are there. Batting order doesn't matter. It will not change the cricket team. So from 100, you need to select 11. How many ways are possible? That many sets of cricket teams are possible. So there will be n factorial by r factorial into n minus r factorial. So 100 factorial by 11 factorial into 89 factorial. This many ways of selecting 11 people from 100. That many cricket teams are possible. In the previous case, 12 people are there. How many handshakes are possible? Requirement for a handshake is 2 people. So how many sets of 2 people can you select from the 12 people? So 12C2. So n factorial by r factorial into n minus r. 12 minus 2, 10 factorial. That you will get as 66. So 66 sets of 2 people can be selected from 12 people. So that many handshakes are possible. Hence option A, 66. You need to select 3 people from a group of 7 people. How many outcomes are possible? So altogether 7 people are there. You need to select 3. So apply the combinations formula and we'll get the total number of outcomes. Now the combinations formula is like this. Now n people are there, out of which r of them are to be selected, and order doesn't matter. Now whenever order doesn't matter, you can just apply into the combinations formula and you will get the number of outcomes. So r people are to be selected from n. Total number of outcomes is given as n factorial by r factorial into n minus r factorial. So directly substitute into this formula, you will get the total number of outcomes. So here n is equal to 7. 7 people are there, out of which 3 of them are to be selected. So there will be 7 factorial by 3 factorial into 7 minus 3, that is 4 factorial. Now there's a slightly easier way of calculating this. Now when you calculate 7C3, now in the numerator there will be 3 terms, that is starting with 7 and backwards. So that will be 7 into 6 into 5. And in the denominator there will be this 3 factorial, that is 3 into 2 into 1. So 3 into 2 I'll cancel with this 6. So remaining 7 into 5, altogether 35 possible outcomes. Now let us just see a few more calculations so that you will get familiar with that. For example, you want to calculate 10C2. Now while calculating 10C2, in the numerator there will be 2 terms starting with 10 and backwards. So there will be 10 into 9. 2 numbers will be there in the numerator. And in the denominator there will be this 2 factorial. So 2 I'll cancel with 10, it will become 5. So 5 into 9 gives you 45. For example, you want to calculate 8C3. So in the numerator you have 3 terms starting with 8 and backwards. So that will be 8 into 7 into 6. And in the denominator you have this 3 factorial. So 3 into 2 into 1. 3 into 2 I'll cancel with 6. So 8 into 7 gives you 56. So 8C3 is 56. Now in this case 7 people are there, you need to select 3 people. So that will be 7C3. So we'll just see why it is a case of combination. Now 7 people are there. Now you need to select 3 people. Let us say you select the 3 people A, B and C. Now let us change the order. Instead of selecting A, B and C, you can select them as A, C, B. So ABC is same as ACB. That is the same 3 people are selected. So if you change the order, you will not get a different outcome. Or you can select it as CAB. So ACB is same as ABC, that is same as CAB. So if you change the order, you will not get a different outcome. That is why it is a case of combination. So just substitute into the combinations formula and you will get the total number of outcomes. That is the number of ways in which you can select 3 from 7. That will be 7C3. Substitute into this formula. This formula will give you the total number of outcomes. You will get it as 35. Now let us just look at some situations where you cannot apply the combinations formula. For example, 7 people are there and 3 chairs are there. So 3 people are to be selected and they are to be seated on these 3 chairs. So how many seating arrangements are there? Assume that you select 3 people A, B and C. Now assume we'll change the order. Instead of occupying the chairs as A, B and C, we'll seat them as A, C, B. So when they are seated in chairs, you can see that A, B, C is a different seating order from A, C, B. So if you seat them as C, A, B, then it is a different seating order. So ABC is different from ACB, that is different from CAB. So when it is a seating order, it is not a case of combination. So you cannot apply the combinations formula when it is a seating order. But if you are simply selecting 3 from 7, order doesn't matter. You can select them in any order you like. So it is a case of combination. Apply, substitute into the combinations formula, you will get the answer. But if 3 people are to be seated on 3 chairs, then seating order matters. If you change the order, you will get different outcomes. Then you cannot apply the combinations formula. Now let us look at another situation where you cannot apply the combinations formula. For example, 5 numbers are there and 5 alphabets are there. Now you need to form a number plate of a car. The number plate of a car consists of 3 numbers and let us say 2 alphabets. So how many number plates are possible? So out of the 5 numbers, you can select 3 numbers, and out of the 5 alphabets, you can select these 2 alphabets. Now if you interchange the numbers among themselves, or if you interchange the 2 alphabets among themselves, you will get a different order, or you will get a different number plate. So if you change the order, you will get a different outcome or a different number plate, in which case you cannot apply the combinations formula. So when you are forming numbers, when people are seated on chairs, when you are forming number plates, if you change the order, you will get a different outcome. Then you cannot apply the combinations formula. So let us look at all the typical situations where you can use the combinations formula. Now one is geometrical figures. Now, let us say some points are given. How many line segments are possible? Requirement for a line segment is 2 points. For example, you choose the points A and B. So you will get the line segment AB. Now, instead of selecting AB, you select it as BA. So you can see that AB, the line segment AB is actually same as BA. So if you change the order, you will not get a different line segment. AB is same as BA. Similarly, some points are given. How many triangles are possible? Requirement for a triangle is 3 non-collinear points. Now you select the points A, B, C. You will get the same triangle as ACB, and the triangle will be same as CAB or CBA. So order of choosing the points doesn't matter. 3 points are necessary for a triangle, but you can choose them in any order. You can see that the triangle is same. So all these geometrical figures, generally it is a case of combination. Now another one is inviting people for a party or inviting guests for a party. Now let us say 5 guests are to be invited. You can invite them in any order. The party will be the same. So you can invite 5 people, A, B, C, D and E. Or you can invite them as A, B, C, E and D. So if you change the order of inviting the guests, it won't make any difference. It is A, B, C, D is same as A, B, C and E and D. So if you change the order, you will not get a different outcome. Party will be the same. It will be the same 5 people. Now another one is cricket teams. For a cricket team, you need to select 11 people. You can select them in any order you like. You can change the batting order, but cricket team will not change. So all these geometrical figures, inviting people for a party, cricket teams, they are all a case of combination. So in the previous question, here 7 people are there. You need to select 3 people. So you can select them in any order you like. It is not a seating order. So if you are selecting 3 people, you can select them as ABC. That will be same as ACB. So order doesn't matter. So whenever order doesn't matter, the total number of outcomes is given by the combinations formula. So in how many ways can you select 3 people from 7? So that will be 7C3. Just substitute into this formula, you will get it as 35. Hence 35 possible outcomes are there. That is option A. There are 5 girls and 6 boys in a class. You need to select 3 girls and 3 boys. How many outcomes are possible? So altogether 5 girls are there and 6 boys are there. Now you need to select 3 girls and 3 boys. So 3 of them are to be selected from 5 and 3 from this 6. Now this and this, so you have to multiply. So first we'll find out the number of outcomes when you are selecting 3 girls from the 5 girls. So from the 5 girls you are selecting any 3 and the boys also. Since and comes, you have to multiply. 3 boys from the 6 boys. This and this. So we will use the shortcut method that was done in the previous question. So to calculate 5C3, in the numerator there will be 3 terms starting with 5 and backwards. So 5 into 4 into 3, and in the denominator you have 3 factorial, 3 into 2, and 6C3. So starting with 6 and backwards 3 terms will be there. 6 into 5 into 4, and denominator you have 3 factorial, 3 into 2 into 1. So 3 and 3 cancels out, 2 cancels 2 times. So 5 into 2, that is, this is 10. Here 3 into 2 cancels with 6, 5 into 4 is 20. So 10 into 20 gives you 200. So altogether 200 possible outcomes are there. This and this, so you have to multiply. So 10 into 20 gives you 200 possible outcomes, option D. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only rupees 200. So all that you need to do is make a payment of rupees 200 either through Google Pay or through Phone Pay or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.